In this class, we're going to consider the quotient rule for differentiation. So in mathematics, a quotient refers to a division or a fraction. So we apply this rule when we've got a function that we need to differentiate, and the function is written as the quotient of two other functions. So just like these three guys here. So usually it's quite easy to recognize when you've got to use the quotient rule, because it will literally be written as a fraction most of the time. So in general, what we're looking at here is to take the derivative, let's say with respect to x, of some quotient, so some f of x divided by g of x. Now in reality, your f and g are not going to be explicitly defined. It's not going to be, you know, f here and g here. It's just going to be some function written algebraically divided by some other function. So like these guys here, this is just what we're talking about in general terms. This is what you're looking for. And the way that this works is not really very intuitive, because you might intuitively think that the derivative of this quotient would be the quotient of the derivatives. In other words, do I just take the derivative of the top and the derivative of the bottom and then divide them? But it doesn't quite work like that. Like the product rule, actually, it's not intuitive. The product rule doesn't really give you the result you might think. The same with this one, the quotient rule. And the way it does work is that we evaluate this derivative by taking the derivative of the top function, so in my case here, f of x, to get f prime of x or f dash x, and we multiply that to the bottom function. So f dash x, g of x, and then we subtract from that the derivative of the bottom function, so g of x in this case, times the top function, f of x. Okay, and then we divide all of that by the bottom function squared. So g of x all squared. So it's a little messy. The algebra is quite large. There's quite a lot of it. But the order is really important here. Unlike the product rule, if you've already seen the product rule, because the product rule uses a plus here, it doesn't matter on the order in which you do things. There's a little bit of personal preference there almost. But with the quotient rule, because it's a minus is always more sensitive to getting order correct. So it is important that you get the derivative of the top function times the bottom function minus the derivative of the bottom function times the top. And there's a whole bunch of sort of acronyms out there to help you remember that. You may have learned those already from another teacher or in your math class, but whatever way you need to remember it is fine, but this is basically the formula that you're going to apply. Excuse me. So let's go ahead and have a look at this example here. And you'll see various formats of example of the quotient rule. So this one's fairly straightforward. We've got these quite simple functions here, a little bit more complicated here, and you'll quite often see them with trig functions in them as well. Now in this series we have not reached differentiating trig functions yet, if you've been watching these videos sort of in order, so I'll just help you out when we get to this one, but it's a fairly simple derivative. But I just wanted to include that here because it is quite a common format type. Okay, so let's have a look at this one. So we're going to you can just go straight into defining your derivative here. And usually then we need a line of work in to tidy up some of the algebra, because we get quite a lot of algebra. So I might actually not quite squeeze it in here. So the way we're going to do this is the derivative of the top, which is just 3 using the power rule. So it's just 3 times the bottom function. It's not the derivative of the bottom function, it's just the bottom function. So derivative of the top, that would be like the f prime of x. In this case here, f prime of x, derivative times bottom, minus the derivative of the bottom function, which is 2x, times the top function. Okay, and then it's all of that divided by the bottom function squared, which you're just going to have to write as x squared plus 1 all squared. And you'll find that quite often the bottom function is usually going to be something which you cannot really square directly. I mean, it might be, like here you could just put an x squared on. This one will actually work out quite nice because it will cancel the square root. But a lot of them are in this kind of format, like multiple terms, and you're just going to put it all in a bracket and square it, okay? Right, so what we can do here is tidy up the top line. So if we multiply out those brackets, we're going to get a 3x squared, but then we've got a minus, well, actually, let's just do it step by step. So we're going to get a 3x squared plus 3 by multiplying out the first bracket, and then we're going to get a minus 6x squared plus 4x from the second bracket. So as I suspected, I'm going to have to move my example out of the way. A little bit too ambitious there with not leaving enough space, and then it's still all of this over the bottom line squared. We're probably not going to do anything with the bottom line in this one. We're just going to leave it. There's going to be no advantage, I don't think, to multiplying out that bracket. You want to leave it in its most compact form. So just looking at the terms here, we've got a number term, we've got an x term, and we've got two x squared terms that we're going to combine. The x squared terms are going to turn negative. So we're going to write this trinomial, because it is a trinomial backwards. So we're going to write it with a number term first, 3 and then plus 4x, and then minus 3x squared. And that's just really to keep it neat because of the minus term on the x squared, minus on the x squared term, I should say, and then all of that over x squared plus 1 all squared. Okay, and that's pretty much as far as that one will go. There's no real other way to do this rule. Like sometimes with the product rule, for example, you can manipulate the original function. For example, if it's written in brackets, by multiplying out the brackets and then using the power rule. In this case, there's no other option other than the quotient rule, and you've just got to work it through step by step. Right, let's quickly scoot on to the other example I had, which was f of x equals, I think, x plus 1, was it, over x square rooted? I think, something like that. First thing to notice in this example, the square root of x is not in a differentiable form, so we're going to have to use our exponent rules to rewrite that as x to the 1/2 power, okay? So that might happen in these as well. Any type of rule you're using for differentiation, you've always got to look for terms that are in a non-differentiable form. Using some special rule, like the quotient rule or the product rule, doesn't take away the fact that terms might still not be differentiable, so you've still got to think about the differentiability of the terms. Okay, so let's go ahead and take our f prime of x. So derivative of the top function, in this case it's quite simple, it's just 1. Using the power rule, it would just be the coefficient basically of that term. So that's just going to be 1 times the bottom function, which is x to the 1/2. And then we're subtracting from that the derivative of the bottom function, which is 1/2 x to the minus 1/2 using the power rule, times the top function, which is x plus 1. All of that over the bottom function squared. Now when you square a square root, like I said earlier, that just cancels out the square root, so that's just going to be all over x. Okay, we can go a little bit further with this one. Let me see, I'll maybe just put it over here actually. So this term is just on its own, so there's nothing we can do with that one. We'll just leave that as x to the 1/2. This bracket we can multiply out, so we've got minus 1/2, and then we've got x to the minus 1/2, but remember this x has really kind of got a power of 1 on it, so using our exponent rules to add the powers, that's going to become 1/2 x to the positive 1/2, because it's minus 1/2 plus 1. And then we're going to have minus 1/2 x to the minus 1/2 times 1, which is just minus 1/2 x to the minus 1/2. Okay, so a lot of half powers going on here. And then all of that over x. This can go a little further, I think, because here we've got 1x to the half minus 1/2. Oh, sorry, 1x to the half minus 1/2 x to the half. So that's just like 1 minus 1/2, which is 1/2. So that's going to give us 1/2 x to the positive 1/2. Then we've got minus 1/2 x to the minus 1/2. All of that over x. Okay, now we could go further with this one. In fact, I'll maybe just quickly pull it up here to finish off. So we can divide each of these terms by the x on the denominator. Remembering this is really an x to the 1, using the exponent rule, so subtracting the powers. So this first term would become 1/2 x to the 1/2 power minus 1, which is x to the minus 1/2 power. This guy is going to become minus 1/2 x to the minus 1/2 power, because it's minus 1/2 minus 1, minus 1/2, which we're going to write as minus 3 over 2. Okay, could go a little bit further with this one, but I think we'll stop at this point. We could turn these into positive exponents. We could pull out a common factor of 1/2. So it could go a little further, but I think we get the point with the quotient rule. So I'll maybe just say dot, dot, dot for that one. You could go a little further there. Okay, let's have a look at the last guy here. So f of x equals sine x over 1/2. So just always asking yourself for these questions, is it in the correct format to use the rule that I think I should use? So the quotient rule definitely applies here. We've got a function over a function, so we can go straight into using the rule. So f prime of x equals the derivative of the top. Now the derivative of sine is just cosine, so I'll just put that out there now in case you're not familiar with those already. So it's the derivative of the top times the bottom function, so it's times x, I'll just put that in a bracket, minus the derivative of the bottom function, which is just 1 in this case, the derivative of x is just 1, times the top function, which is sine x, all of that over the bottom function squared, x squared. This is quite an unusual example, or not unusual, but specific example, in the sense that most of these, as you saw with these two, can go quite far with the algebra after you've taken the derivative, because in this case here, we actually took the derivative at that line, and we did a few more lines of tidying up, and we took the derivative here, and we carried on all the way over here, and we could have probably carried on for another 2 or 3 lines potentially there. But this one, once we've gone to this point, there's nothing else we can really do. There's no simplifying, there's no algebraic terms, we can't combine anything. So we're basically done with that one. So that one does only require sort of 1 line of working. So that's basically how we use the quotient rule. So learn the rule, learn it in your own words if you have to. I mean, it's good to know the kind of sort of formula, but sometimes it's better to formulate these in your own way of thinking. So you might come up with your own acronym for how to remember this. I personally just remember it as the derivative of the top times the bottom minus the derivative of the bottom times the top divided by the bottom squared. That's just the way that I have learned this, but you can learn it your own way. But the key really with all of these differentiation rules, product rule, power rule, quotient rule, and then the other rules you're going to learn as well, is trying as many different formats as you can. Because notice that guy, and this guy here are very different looking functions. They're nothing really like each other. So it's important to try different styles of function, different formats, so that you learn to apply this rule not in just the same way over and over again, but in many different scenarios, so that when you see it on a test or an exam or something like this, you're not thrown off. You know it's the same type of procedure, it's using the same rule, it's just adapting it and not being sort of visually put off by the fact that you see different functions there. So learn the rule and then check out some practice questions.